Up until now, we've focused exclusively on square roots, but roots don't have to be square roots. They can have an index other than 2. For example, we could have the nth root of m. And as we've said at the beginning, that n written in there is the index. And that is how many factors are needed to clear the radical. And so as we're simplifying, we're not just dividing by 2. We're not just dividing exponents by 2. We're dividing the exponents by the index. So for example, if I had the 4th root of a to the 13th, b to the 23rd, c to the 10th power, I'm saying what to the 4th power could clear this root. So now when I look at that 13th exponent on a, we divide it by the 4 to see how many a's come out and how many are left behind inside the 4th root. Well, 13 divided by 4 is 3, remainder 1. So 3 come out, 1 remains. Then I do the same thing with the b to the 23rd. 23 divided by 4 is 5, remainder 3. So 5 come out, and 3 remain. Same thing with c to the 10th. 10 divided by 4 is 2, remainder 2. So 2 c's come out, and 2 remain. So we have a cubed b to the 5th c squared times the 4th root of ab cubed c squared. So we're following much the same process we had with the square roots, but now we're dividing by the index of 4 instead of the square root. Also notice that index needs to be in my final answer, because if I don't write an index, that means what I'm really saying is a square root. And we're not doing square roots here. We're doing cube roots. Let's try one more example. Let's do the cube root of 750. Well, just like before, we have to factor that number. 750, that's going to be 2 times 375. That's going to be 3 times 125. That's going to be 5 times 25. And that's going to be 5 times 5. So now we've got the cubed root of a 2, a 3, and a 5 cubed. To simplify, I'm going to divide exponents by the index to see what comes out and what's left behind in the cubed root. Notice the 2 and the 3 do not have exponents on them, so they're going to stay in the cubed root. But the 5 cubed, I can do 3 divided by 3 to get 1 5 coming out and no 5s left behind. Simplifying then, multiplying the 2 times 3, we end up with 5 times the cubed root of 6 for our final answer. So when working with other roots, the process is still the same. We just need to make sure we have 3 things to clear a cube root, 4 things to cube a 4th root, or whatever the index might be for your problem. Now it's your turn to go and practice some of these and see how you do. Let your instructor know if you have any questions.